So our next topic is like VI characteristic we have done, static and dynamic resistance we have done, and diode current equation based numerical we have done. Now we need to do the next topic, that is Zener diode. Okay, so Zener diode is little bit different from the normal diode. First of all, Zener diode symbol is like this. Like ये तो normal diode का symbol हो गया. अब इसमें हम ऐसे बना देंगे तो this one is the Zener diode. ठीक है? So Zener diode mainly works in the condition of reverse bias. ये reverse bias की condition में ही काम करता है. First thing. Second thing, Zener diode always work as a voltage regulator. वो voltage regulator की तरह काम करता है, means it needs to maintain the output voltage as a constant. इसका मतलब तुम इनपुट में कितनी भी वोल्टेज दो, आउटपुट वोल्टेज must be constant. Like suppose you are using stabilizer at your home, stabilizer, voltage stabilizer you are using na in air conditioner. So why we are using this? Because input voltage can be fluctuating from 200 to 240 volt, but our AC needs 220 volts. So this will work as a voltage regulator. Similarly, Zener diode will work as a voltage regulator. Okay, clear? So इस पे one question क्या बनता है तुम्हारा? First of all, जिसके high chances होते हैं, that is numerical based on Zener diode. ठीक है, जो जनरली आता है, बट जो आजकल आने लगा है last 2 years से, that may be the theory that is based on line regulation और load regulation पे ये difference पूछ लेते हैं. Next thing they can ask you the Zener breakdown या फिर avalanche breakdown. Okay, so first of all we'll do numerical. कि numerical इसका कैसे आता है. We'll have standard diagram for Zener diode numerical. Like इसमें क्या होता है, we'll have one Zener diode like this. Zener diode के parallel में our load resistance is connected, that is RL. Okay, and for this resistance, series resistance, and here we'll give the supply voltage, that is denoted by VS. ठीक है, VS is the supply voltage. मान लो ये तुम्हारे घर का सर्किट है, ठीक है, तो VS is the supply voltage दो गवर्नमेंट की साइड से आ रही है. ओके, सो समटाइम दे कैन कॉल्ड इट एज इनपुट वोल्टेज, एक ही बात है, तो दैट इज डिनोटेड बाय VI. तो इनपुट वोल्टेज VS या ऐसे कुछ कहेंगे तो ऑल दीज आर द सप्लाई वोल्टेज. दिस इज लोड रेजिस्टेंस. लोड रेजिस्टेंस लाइक तुम्हारे घर का AC विच नीड्स टू बी मेंटेन आउटपुट वोल्टेज कांस्टेंट, राइट, कि घर से सप्लाई आ रही है और ये AC लगा रखा है और इसकी आउटपुट वोल्टेज कांस्टेंट होनी चाहिए. So voltage across load resistance would be denoted by VL. VL is the load voltage. Sometime they can call it as V naught. तो V naught और VL एक ही बात है. VL मतलब लोड वोल्टेज है, V naught मतलब आउटपुट वोल्टेज है. ठीक है, तो सो डोंट गेट कंफ्यूज. नोटेशन इनकी पेपर में चेंज होती रहती है. Manipal don't use fixed notation. And इस केस में like current, suppose the total current is I. ओके, या फिर सप्लाई है तो IS से डिनोट कर दो, लोड में जा रहा है तो IL से डिनोट कर दो, जीनर में जा रहा है तो IZ से डिनोट कर दो. ओके, समटाइम अगेन लोड करंट की जगह दे कैन रिप्रेजेंटेड बाय I नॉट, दैट इज द आउटपुट करंट. ओके, IZ इज द जीनर करंट एंड द वोल्टेज अक्रॉस जीनर वुड बी VZ, राइट. Sometimes they can ask you the power across Zener. So power का formula is I square R, one of the formula, या फिर PZ is equal to VZ into IZ. तो जब भी power they'll ask you, we don't use this formula because we don't have resistance for the Zener diode. Correct? We don't have resistance for the Zener diode, so we'll always use this formula for the power. VZ, that is the voltage across Zener multiplied by the IZ. ठीक है, note it down. Now take out your formula page as I told you the formula. Now put a heading over there, that is Zener diode. ठीक है? So Zener diode formula is based on two conditions. Either Vz can be greater than VL and either Vz can be less than VL. Okay, if these are the two conditions, then in that case उसके अकॉर्डिंग तुम्हारे फॉर्मूलेस मैनिपुलेट हो जाएंगे, चेंज हो जाएंगे. ओके, like suppose in the first case if Vz is greater, then that means Iz is less. Yes or no? So if Iz is less, so we can consider Iz is equal to 0. If Iz is equal to 0, as you know, this is the circuit, that means no current is flowing through the Zener diode. Correct? No current is flowing through the Zener diode. That means it's an open circuit. Correct? So this would be Vs, this is Is, this is Rs, this is RL, and this is IL. Correct? So in this particular case, Iz is equal to 0. So what we can write down? Is is equal to IL, right? Or we can use according to Ohm's law, Is is equal to V by R. V is what over here? V is Vs divided by Rs plus RL, because now Rs and RL are connected in series. Correct? So we can use this formula, and in this case VL is not equal to Vz. Okay, because Vz is open circuit, तो इसमें इसकी voltage और इसकी voltage अलग होगी. Now the thing is कि how we can check that we are working on first condition or we are working on second condition. So for this particular you have to use one formula. VL का formula होता है VL is equal to Vs into RL divided by Rs plus RL. ये तुम्हारा voltage division rules आएगा, that you need to study in BET. अब BET में पढ़ोगे VDR. तो अभी तो मैं फिलहाल तुम्हें डायरेक्ट फॉर्मूला ही बता रही हूँ. ठीक है, फॉर्मूला मैं थोड़ा सा बता ही देती हूँ. चलो, एनीवेज, इफ सपोज विल हैव टू रेजिस्टेंस इन सीरीज. ठीक है, दो रेजिस्टर सीरीज में है R1 एंड R2 एंड वी नीड टू कैलकुलेट द वोल्टेज अक्रॉस R2. सो वी कैन यूज वन डायरेक्ट फॉर्मूला, और उस फॉर्मूले का नाम होगा दैट इज वोल्टेज डिवीजन रूल, that you need to use in BET also. ठीक है, so see what is the formula for VR2. क्या formula होता है इसका? Total voltage. How much is the total voltage for this particular case? V multiplied by जिस branch में हमें voltage निकालनी है, that resistance, that is R2, divided by the sum of resistor which are connected in series. So which two resistor are connected in series? That is R1 plus R2. Okay, so now apply the same thing over here. In this particular case we need to calculate voltage across RL, that would be VL, right? So VL is equal to total voltage. Total voltage over here is Vs into RL divided by the sum of resistor which are connected in series, Rs plus RL. ठीक है, so by using this formula we can check कि Vz बड़ा है या Vz छोटा है by calculating VL. Maximum times they'll give you the Vz value. Understood? Okay, now for the second condition, Vz is less means Iz would be more. Correct? If Iz would be more, then we'll draw the proper standard circuit as I told you, that will have the Zener, will have the load resistance RL, will have the Rs, and this one would be Vs. The current flowing over here would be Is, here it would be Iz, and here it would be IL. So what we can say that Is would be equal to Iz plus IL, right? So as you know, here the voltage across load resistance would be VL, voltage across Zener would be VZ. So can we say that VZ is equal to VL because these are connected in parallel? Exactly. So according to Ohm's law, we can also say that VL is equal to IL into RL, right? And for PZ power across Zener diode, that would be VZ into IZ. Okay. Now one more formula left, that was for IS. IS would be how much? Like V by R, है ना? So if we want to calculate IS, then resistance would be RS. Yes or no? VS minus VL, voltage would be VS minus VL, because total voltage, जैसे तुमने total voltage, suppose you have given 100 volt and from that 20 volt is consumed by the Zener. So how much is the left voltage for the RS? 80 volt now. So that's why we are using this formula. IS would be equal to VS minus VL by RS. Okay, clear? One more thing, sometime they'll give you the minimum Zener condition, minimum Zener current, maximum Zener current, maximum current. So whenever they'll say ki minimum and maximum condition, so in that case we always need to use second condition. When we'll do numericals, it would be more clear to you. Okay? So write it down, this thing, all these formulas. If you learn all these formulas, then Zener diode is easy for you. See, this is the question of 2023. They said draw the Zener voltage regulator circuit. Okay, so resistance and Zener diode and RL. This is the standard circuit, right? So now they said a Zener diode has a breakdown voltage of 10 volt. Means VZ is equal to 10 volt. It is supplied from a voltage source between 20 volt and 40 volt. 20 volt and 40 volt between. So one voltage will consider 20, then maximum will consider 40. With a resistance of 820 ohm. 820 ohm is this one resistance, that is RS. Load resistance is 1 kilo ohm, means 1000 ohm. Now we need to obtain the minimum and maximum Zener current. We'll take IZ. We need to calculate IZ minimum and we need to calculate IZ maximum, right? So see, what was the formula for IZ first? Like suppose we'll have IS over here, IZ over here and IL over here, correct? So see, if you'll see the formula page, that is this one. I mentioned here that IS would be equal to IZ plus IL. So tell me, IZ would be how much? As I told you, minimum and maximum is, so we have to use second condition only. So IZ would be how much in this case? No, for this question, IZ would be equal to IS minus IL now. Okay. So I'll put the formula IZ is equal to IS minus IL, right? So if I'll consider IZ minimum, so IS also and IL would be maximum. So abhi filhal we need to calculate IL. So according to Ohm's law, IL का क्या formula होगा? VL by RL होगा. VL is equal to VZ. Yes or no? इस केस में VL और VZ equal होता है, parallel होता है, तो VZ by RL. Correct? VZ is how much? 10. They have mentioned. RL is how much? RL, load resistance, 1000. So that would be 1 by 100, right? ठीक है? So we can convert it into milliampere because current would be in milliampere. ठीक है? We can get IL. Now next we need to calculate IS, right? So IS is how much? VS minus VL divided by RS. VS, अगर मैंने IZ minimum लिया तो voltage भी हम minimum मिलेंगे. So that would be 20 minus VL is 10 क्योंकि VL is equal to VZ divided by 820. So can we get the IS value from here? We can substitute over here. Then the current would be in the milliampere. Okay, we'll get the IZ minimum. Same procedure we need to repeat by using IZ maximum. This time we have taken 20 volt, next time we'll take 40, then we'll get the answer. See, in this case VZ is 50 volt, right? So minimum and maximum wala case hai, so we have to use second condition. VZ is equal to VL is equal to 50 volt, right? So if we know the value of VL is 50, if we know the current, can we get RL? According to Ohm's law, VL is equal to IL into RL. So this is only one value, not its मतलब minimum and maximum है तो हर चीज vary नहीं करेगी. Okay, so VL is 50 and this is 25 milliampere. So you will get the resistance RL in kilo ohm, right? You will get some particular value. So 50 by 25 into 10 raised to power 3, correct? So you will get 2 kilo. Now you need to calculate V in, that is VS. मैंने बोला था ना कहीं ये VS यूज करेंगे, कहीं VI और कहीं VN. तो तुम्हें मैंने फॉर्मूला जो बताया वो क्या है, IS is equal to VS minus VZ by RS. This formula I told you. Okay, so RS value we know 3.75 kilo ohm, right? VZ value we know that is 50. We just need to calculate VS that they have asked, but we need to know about the IS also. So can we say that IS is equal to IZ plus IL? So IZ minimum होगा तो IL would be, IL तो एक ही है, that is they have given 25, right? So if we take IZ minimum, that is 5 plus 25, right? IZ minimum is 5. Then can we get the IS minimum value? That would be 30. So we can substitute the 30 milliampere. Then we can get VS minimum, right? Then again in the next case, now we'll substitute IZ maximum, that is 40. So 40 plus 25, that would be 65. So again we need to substitute the value of 65 milliampere over here. Then we'll get VS maximum, right? देखो इसमें draw the circuit of Zener regulator. As I told you, this is the standard circuit, right? And in this Zener regulator, VI is 16 volt, RS is 1 kilo ohm, VZ is equal to VL, so VZ is equal to 10 volt, RL is equal to 3 kilo ohm. We need to calculate V naught. V naught is equal to VL is equal to VZ, that is 3 kilo ohm, right? As we have checked the condition, so VL is equal to VS into RL divided by RS plus RL, तो हमारी second condition आएगी. So from here we'll get VL as 12 volt, right? तो V naught आ गया. Next is IZ. IZ का formula, as you know, IS is equal to IZ plus IL. So tell me, what is the formula for IL and what is the formula for IS? Check your formula page. Yeah, so this was the question. Now I'm telling you line regulation and load regulation. Okay, see what is line regulation and what is load regulation. One is line regulation, comparison से याद करोगे तो that would be better for you. Another one is load regulation. Okay, so line regulation is like this कि हमारे पास supply voltage है, Zener diode है, and we'll have load resistance. इसमें क्या होता है, इनपुट वोल्टेज वेरी करेगी, ठीक है। देखो मैंने ऐसे एरो बनाया ना, एरो मीन्स इट इज वेरिंग, सो इनपुट वोल्टेज इज वेरिंग बट लोड रेजिस्टेंस इज कांस्टेंट। क्लियर? सेम डायग्राम आई एम ड्राइंग हियर, स्टैंडर्ड डायग्राम। अब इसमें क्या होगा, दैट लोड रेजिस्टेंस इज वेरिंग, ओके, बट इनपुट वोल्टेज इज कांस्टेंट। समझ गए दोनों में डिफरेंस? लाइन रेगुलेशन मीन्स load resistance is constant and input voltage is variable, and but in this case input voltage is constant and load resistance is variable, ठीक है। ओके, नाउ अब इसमें देखो हमारे पास व्हाट वी हैव, लोड रेजिस्टेंस इज कांस्टेंट, दैट मींस द वोल्ट, अभी वो तुमने अभी केस भी पढ़ा है कि हमने ये वाला केस पढ़ा है कि लोड रेजिस्टेंस इज कांस्टेंट एंड इनपुट वोल्टेज इज वेरिंग। सो इफ लोड रेजिस्टेंस इज कांस्टेंट दैट मींस VL is also constant, and if VL is also constant then VZ is also constant, correct? तो if Vin is varying, तो Vin is varying, then current IS, यहाँ से जो करंट निकल रहा है that is IS, that also vary, yes or no? And if IS is vary, तो IL is constant, right? क्योंकि यहाँ पे जो भी चीज होगी वो कांस्टेंट होगा और यहाँ वाला चीज वेरी करेगी, करेक्ट? तो बेसिकली एज आई टोल्ड यू इन द स्टार्टिंग ऑल्सो कि हमारा एम क्या होता है कि हमें आउटपुट वोल्टेज कांस्टेंट मेंटेन करनी होती है ना। अब इनपुट वोल्टेज वेरी कर रहा है तो कर रहा है, बट आउटपुट वोल्टेज मस्ट बी कांस्टेंट। अब वो देखो कैसे होता है, विल हैव फॉर्मूला IS इज इक्वल टू IZ प्लस IL। अगर IS की वैल्यू कम होगी तो ये अपनी IZ जीनर करंट ज्यादा कर लेगा, बट ये हमेशा कांस्टेंट रहेगा। ये ज्यादा होगी, ये कम कर लेगा, IL हमेशा कांस्टेंट रहेगा। मेन हमारा टारगेट क्या है कि IL कांस्टेंट होना चाहिए। ये कम हो रही है तो जीनर डायोड अपने अंदर ज्यादा करंट ले लेगा, और नहीं ज्यादा हो रही है तो वो अपने अंदर कम करंट लेगा। तो बेसिकली जो काम कर रहा है वो जीनर डायोड करंट कर रहा है, ओके। सेम इज द केस ओवर हियर, हियर Vin इज कांस्टेंट, राइट? तो यहाँ से जो हमारे पास IS आएगा, IS is also constant, yes or no? So in this case IS would be equal to IZ plus IL, स्टैंडर्ड फॉर्मूला। ये क्या है? कांस्टेंट। ये क्या है? वेरी। बट मैं चाहती हूँ कि आउटपुट वोल्टेज कांस्टेंट रहे, राइट? तो उसके लिए IZ को भी क्या करना पड़ेगा? वेरी करना पड़ेगा। मान लो दिस इज 10 एम्पियर, ओके, और ये क्या है हमारे पास, एक बार 8 एम्पियर, तो ये कितनी हो जाएगी? 2 एम्पियर, और ये अब 9 एम्पियर हो गई, तो इस ये कितनी हो जाएगी? 1 एम्पियर। सो वी वांट कि आउटपुट वोल्टेज मस्ट बी कांस्टेंट, ओके, इन बोथ दीज कंडीशन।